So while it's difficult to have an example of every kind of sample statistic that can show up, we can at least summarize what the different possibilities are here. Typically we look at means, not so much the medians. So in this first group here, we'll generally be looking at a mean. Bootstrapping for the median or the standard deviation is also possible, but bootstrapping for the mean and inference about the mean is more common in an introductory statistics course. So we'll say this is when we're interested in inference about the parameter mu, because that's what we would use for a population mean. And this would go with data that are represented by one quantitative variable. When our question only refers to one quantitative variable, we might look at a mean and we would call it mu, and we would estimate it with the statistic x bar, right? X bar is going to be the center of our confidence interval. For a single proportion, we would call that parameter p, and this would be if we have one categorical variable. And the statistic that we would use to estimate p, and the statistic that our bootstrap distribution would represent, is p hat. For a difference in means, that would be mu1 minus mu2. This is where the questions get a little more interesting usually, is when we're comparing two things. And this is where we have really one quantitative and one categorical variable, because the means have to be a measure of the same variable. It doesn't really make sense to compare mean shoe size to mean height. When you subtract those numbers, you get something completely meaningless. So you'd have to subtract mean shoe size from one group from mean shoe size from another group. And the grouping is where that categorical variable comes in. So this is one quantitative and one categorical variable, realizing that the categorical variable can only take on two values for this to work, or we have to at least only be looking at two values of the categorical variable. And the sample statistic that we would use to estimate this difference of parameters is x1 bar minus x2 bar. Now, for a difference in proportions, same idea, p1 minus p2. This is if we have two categorical variables, because the proportions have to come from different groups. We can't really do this for two proportions in the same group. But we'll get into that a little bit more when we talk specifically about differences of proportions. So this sample statistic would be p1 hat minus p2 hat. And for slope and correlation, the parameter, remember, is rho. And we would have to have two quantitative variables. And the sample statistic we use to estimate rho is r, lowercase r. So each of these shows us what the parameter is that the confidence interval represents. The confidence interval always represents the population parameter. So the confidence interval is for rho, or is for p1 minus p2, is for mu1 minus mu2, is for p, is for mu. But the sample statistics that we use to find the confidence interval are these ones that show up in parentheses here, right? And these are generally where the confidence interval is centered, unless we're using the percentile method, and then that sample statistic will certainly be in the confidence interval, but it might not be dead center in those cases.